Hi everybody, welcome to today's lesson on formal fallacies. Today we will be discussing the undistributed middle term fallacy. First we'll take a look at a few examples of how the undistributed middle term fallacy is employed in natural language as a means of argumentation. Then we'll take a look at a few of its forms, and finally we'll take a look at a proof of its invalidity. So let's get right into it. Before we take a look at these examples, let me preface the examples by saying this. The undistributed middle term fallacy can be employed in a number of different ways. We can employ it by means of propositional logic through material implication. We can also employ it by means of predicate logic by quantifying over expressions. And we can also employ it by categorizing certain aspects of nature. So the first example starts with premise 1. If the animal I see is a cat, then the animal I see is a mammal. Premise 2. If the animal I see is a dog, then the animal I see is a mammal. Therefore, if the animal I see is a cat, then the animal I see is a dog. Intuitively, it's pretty easy to tell that this is an unsound method of reasoning. It makes a category error insofar as cats are not dogs and dogs are not cats. The second example starts with premise 3. It says all cats are animals. Premise 4. All dogs are animals, therefore all cats are dogs. Here we have the same problem as the first example with the category error. The third and fourth examples are a bit trickier to tell that they are unsound. The third example starts with premise 5. If John lied, then Mary told the truth. Premise 6. If Sam told the truth, then Mary told the truth. And therefore, if John lied, then Sam told the truth. And the last example starts with premise 7. If I have 1 apple, then I have less than 5 apples. Premise 8. If I have less than 3 apples, then I have less than 5 apples. Therefore, if I have 1 apple, then I have less than 3 apples. Although the math may seem to check out here, the form in which the argument is presented is invalid. Let's take a look at a few of its forms. The first form that we may encounter the fallacy is in the set theoretic notation. So we have premise 1, A is a proper subset of B. Premise 2, C is a proper subset of B. Therefore, A is a proper subset of C. To help think about this a little bit more clearly, we can use a diagram, a couple of them. So premise 1 says A is a proper subset of B. So what we can do is draw a circle, and we can say that this is set B. We could draw a circle inside set B and say that this is A. And now we have a visual representation of the statement that A is a proper subset of B. Premise 2, we can do the same thing. Draw a circle, we'll call that set B. And we'll say that C is a proper subset of B. And we conclude that we have a set C here, and that A is a proper subset of C. The second form in which this fallacy can be presented is in predicate logic. So we can say for all x, if x is P, then x is Q. Premise 2, for all x, if x is R, then x is Q. Therefore, for all x, if x is P, then x is R. And the third form of this fallacy is within propositional logic. Premise 5 says P implies Q. Premise 6 says R implies Q. And we conclude that P implies R. And this is the form that we will be using to check the validity of this argument. So to get its propositional form, we'll take the first two premises here, and we'll make a conjunction out of them. And we'll take the therefore symbol, and we'll change it into implication. And we have to ask ourselves, is this form true in every interpretation? In order to do that, let's hop over to Excel and fill out the truth table that we have here. What you see is the skeleton of the truth table. All we have to do is punch in our values to figure out whether or not this form is valid. Because we have 3 propositional variables, we will have 8 different interpretations. And the trick here, for our first propositional variable, we're going to insert 1s for the first 4 interpretations, and then 0s for the last interpretations. In our second propositional variable, we're going to cut that in half. So we'll do 2 1s and 2 0s, but we still have we still have 4 more interpretations, so we'll just repeat that again. 1 1 and 0 0. And for our last interpretation, all we're going to do is cut that in half, what we did for Q, so we're just going to alternate between 1 and 0. And we can see here we have an interpretation where all 3 propositional variables are true. We have an interpretation where P and Q are true and R is false. We have an interpretation where P and R are true and Q is false. We have an interpretation where P is true and Q and R are false. We have an interpretation where P is false and Q and R are true. We have an interpretation where P and R are false and Q is true. We have an interpretation where P and Q are false and R is true. And we have our final interpretation where none of the propositional variables are true. And this gives us a combination of all the possible interpretations that we can have here. So let's copy this over into our other columns while staying consistent. And our next step is to fill out the rest of these expressions. So we have 3 material implications here. We have one in column B, we have one in column F, and we have one in column J. And that's not counting, of course, our main operator here in column H. So we know that the material implication returns a value of false if and only if the consequent is false and the antecedent is true. Otherwise, it will return a value of true. In our first interpretation, both are true, so we'll have a return value of true. Same thing for our second interpretation. Our third and fourth interpretations, P is true and Q is false, so we will have a false return there. And for the last 4 interpretations, we already know that the material implication returns a value of false if and only if the consequent is false and the antecedent is true. Otherwise, it returns a value of true. So for the last 4, we will have vacuous truths. And let's do the same process for the next set. 1 and 1 will give us a value of true. 0, then 1 will give us a value of true. 1, then 0 will give us a value of false. 0, then 0 will give us a value of true. 1, then 1 will give us a value of 1. 0, then 1 will give us a value of 1. 1, then 0 will give us a value of false. And 0, then 0 will give us a value of true. And our last one here, 1, then 1 will give us a value of true. 1, then 0 will give us a value of false. 1, then 1 will give us a value of true. 1, then 0 will give us a value of false. And the last 4, since the antecedents are all 0 here, we'll have vacuous truths. Next, let's take a look at column D. This is our conjunction operator, and we know that the conjunction operator returns a value of true if and only if both conjuncts are true. Otherwise, it will return a value of false. And keep in mind, we will be comparing column B with column F. So for our first one, we have a value of 1 and 1. So we'll get a return value of 1. For the next interpretation, they're 1s again. So we'll get a return value of 1. For the third interpretation, we see that we have both 0s. So we will have a 0 there. In the fourth interpretation, we have a 0 and a 1. So the return value will be false. For the fifth interpretation, we have 1 and 1. So we'll get a return value of 1. Same thing for the sixth interpretation. For the seventh interpretation, we have a 1 and a 0. So we will have a return value of 0. And for the last interpretation, we have a value of 1 and 1. So we'll have a return value of true. And finally, let's take a look at column H, which is material implication. And again, just as a reminder, material implication returns a value of false if and only if the consequent is false and the antecedent is true. Otherwise, it will return a value of true. And keep in mind here that we will be comparing column D, our conjunction operator, with column J. In our first interpretation, we have a 1 and then a 1, so we'll have a value of true there. In our second interpretation, we have a value of 1 for the antecedent and a value of 0 for the consequent, so we'll have a value of 0 as our return value. In the next two interpretations, both antecedents are 0, so we'll have vacuous truths there. In the next interpretation, we have the antecedent as true and the consequent is true, so we'll have a return value of 1. In the next interpretation, we have a value of 1 for the antecedent and a value of 1 for the consequent, so we'll have a return value of 1. And for the next interpretation, we have a value of 0 for the antecedent, but a value of true for the consequent, so we'll get a vacuous truth. And in the last interpretation, we have the antecedent and the consequent both with values of true, so we'll have a return value of 1 there. And there we have it. We can see that the fallacy of undistributed middle is indeed invalid. We can see in our second interpretation that we do have a value of false, and in order for the proposition to be a theorem and or valid, we would need this entire column to be filled with ones. And that's the lesson for today, guys. Thanks for coming by, and until next time, may reason be with you.